Of course, since we're working with the normal curve, that means that we'll be able to find probabilities or sample means to satisfy certain conditions. And we'll use this technology table, which is also in your exam notes packet, to be able to answer those questions. So remember, in StatCrunch, we'll use Stat Calculator's normal, and we can follow these paths depending on what we are trying to find. So let's see an example. And we'll just come back and refer to that sheet as needed. And I'm going to show everything with StatCrunch, and at the end, I'll do the calculator. So if you're using the TID4, you'll be able to see that. So suppose a random independent sample of size n equals 38 is taken from a population where the population mean, that's mu, is 250, and the population standard deviation, that's sigma, is 50. Find the following. Include shaded and labeled graphs. Give 4 decimal places for probabilities, 1 decimal place for x bar, which is a sample mean. All right, so the first thing they want us to do is describe the sampling distribution. Now you'll notice that I tell you right up here that it's random and independent. So we already know that it's random and independent, right? There's condition 1, there's condition 2. The problem didn't ask for it, but if you want condition 3, just to prove that you can describe this distribution, you need your sample size, which is 38, to be bigger than 30, which it is. So that means that when we get down here to shape, we'll be able to say normal. It didn't ask for that, so it wasn't strictly required for this particular problem, but nevertheless, there you have it. All right, so now the center. Okay, well, using the central limit theorem, the center is the mean, and since this is for means, it'll be of x bar, right? The mean of the x bars, mu sub x bar, is equal to mu, right? That's what it says back a couple pages right here. All right, so what was mu for us? It was 250. So that is the center of our normal curve, which we're going to have down here. It's the central of the normal curve that is the sampling distribution. Now our spread is the standard error of the x bar, which is kind of the newer way to write that. That's more modern notation. The more old-fashioned way to write it is sigma with a little x bar after it. And that would be sigma over the square root of n, which is 50 divided by the square root of 38. All right, so we need an approximation for that. So let's get Desmos up. There it is. Hello, Desmos. I'm going to log into the graphing calculator. All right, 50 divided by square root, so SQRT, or you could bring up the square root from the palette. It's that little checkmarky one, and 38. And we get 8.1111, in fact, if I'm going 4 decimal places. So 8.11107. I'll just do that. That way I've got more decimal places than I could possibly need. All right, so now we're going to find P stands for probability. So we're looking for the probability. Right, we're looking for the probability. Now, why do I need to know that? So the probability tells me here, if I want to find area percent probability, they're all the same thing, right? So if I want to find the probability, which I do, I'm going to put my mu in and my standard error of my x bar in. And then I'm going to tell it the x bar here, and it will find the area. It will find the probability, right? Because underneath a normal probability curve like this, the area is the probability. Okay, so let's go to StatCrunch and do that. Now the key with StatCrunch in this chapter and what makes it different, this is the part that everybody loses track of. So in StatCrunch, the calculator doesn't know the difference. It just says mean and standard deviation. But we can't use the same mean and standard deviation that we were given. Well, we can and we can't. The mean is 250 still, right? That's mu, right? Because that is this value right here, right? This value. But the standard deviation is no longer the standard deviation that's given. You don't use 50. You use the standard deviation of the sampling distribution of the x bars, because we're talking about an x bar here, not an x. So you have to use this value. So let's make a note. I'll just kind of star it in red. use these values as the mean, right, which is the center, and the standard deviation in the normal calculator. That's where people make a mistake. If they're going to make a mistake, they see in the normal calculator that it asks for standard deviation, and they think, oh, the standard deviation was 50. But that's the standard deviation of individuals. We're talking about the standard deviation of the sampling distribution, which is this value here. So we have to type 8.1107 into our normal calculator. That's the key. And then it wanted 240, so we put 240 in here. We wanted a less than, so less than's fine, and say compute, and there it is. And now we want to shade our page so that it matches that. So it's not going to be perfect, of course, but we know that the bar where it's landing, that right-hand edge of that red zone, is 240. And we found the probability to be, we can write this out. So the probability that x bar is less than or equal to 240 is 0.1088. I'm writing out that line, and over here is the answer, right? Because the area of that under that curve is the probability. All right, now let's do it again. So, all right, they want to find the 95th percentile of the sample means. Okay, so if I go back here, I'm looking for percentile. Percentile is right here, not percentile rank. Percentile rank is a different thing, but percentile means I'm going to put the area in. I'll put the standard error in and the mu in, and it will find the x bar for me. Okay, so let's see here. 95th percentile, we have to remember or recall that automatically a percentile is the percentage below. It has to be. That's the way percentiles work. So if you're in the 95th percentile, that means 95% of whatever this is below you. So that area is 0.95. Most of the curve is shaded, and you're looking for this value, right? What is that x bar? That's what you want to know. Okay, so let's go back to StatCrunch. We, of course, leave it 250 and 8.11. Those are going to stay for this whole problem. What's going to change is I'm going to go over here and get rid of this area because it's no longer the same problem that it was before. I'm going to put in an area of 0.95, and I want it to be a less than because it's pointing to the left, right, for my shading. So I click compute, and there we have it. And I'm going to write that bottom line. So P parentheses x bar less than or equal to 263.34. Oh, I think I wanted one decimal place for those. So 263.3 is equal to 0.95. So that whole bit is going to get written on my paper. So let me go back to my paper so you can see. There it is. And the answer is actually this value right here. That's the answer. All right, now I'm going to show these same problems with the calculator. So if you're not watching or working on the calculator, you can just skip ahead to the next video. All right, back here on the calculator, the first thing we did was in Desmos, which technically you can use a calculator for. So 50 divided by the square root is above your x squared button, and then you would type 38 and so on. And then to use to do these two problems, you have to use different things. So we would use the normalcdf function to do the first problem and the inverse norm to do the second problem because they work differently. So let me grab normalcdf, which is under the distribution menu, choose number 2. We do want to go from -1e99 up to 240. We want 250 as the mean, and we want 8.1107. And then we go down and paste it, and we press enter, and there it finds that value. All right, to reverse the process, we need to use inverse norm. All right, so now on an old or a new calculator, excuse me, like this, it's pretty easy because you can tell it actually on an old calculator it would be also in this particular case because this was a left tail. So 250, 8.11107, you tell it left and then paste and enter. So there's how to write those. So let me write both of these down just for your own sake. If you're on the TI-84, this is what you write. And again, if you're not using a TI-84, skip ahead. You don't need to see any of this. So it'd be -1 E99. Remember that E is above your comma button. It's the double E on the comma button in blue. So 240, 250, 8.11107. There you go. And then down here on the TI calculator would be inverse norm. That's a V, sorry. Inverse norm. And it'd be 0.95 to 250, 8.11107 left. Now, if you're on an old calculator, the left is not an option. It just automatically is. But let me show you here. So on an old calculator, sorry, you can see my camera up there. There's not much I can do about that. So second distribution, inverse norm, you'd say 0.95, 250, 8.11107, and paste. And that's it. It automatically does left. It doesn't have the left, right, center option the way the new calculators do.